original background is actually robotics and factory automation. So I've been peripherally involved with artificial intelligence for over 30 years because you don't do stuff with robots and robotic work cells. And I was fortunate enough to work in some pretty cutting edge stuff in the aerospace industry when I first got out of school. In fact, the company that hired me hired the whole robotics lab from Texas A&M to come to work for them at an aerospace company out in California. And so we went to do all kinds of really fun stuff for a few years. As you can see, AI's been in the headlines a lot. And some of these are really recent. This one is only a week or two old, okay? Google's now, has AI to build AIs. And I think this is one of the trends that's going to kind of lead to some of that exponential, where it's going to happen. It's going to happen only in very limited areas, but there are some places where it's going to happen. Stephen Hawking warns artificial intelligence could end mankind. I don't think that one's real likely. I think Bill Joy's probably got it nailed, and it's going to be biotech that we have to really be careful of. Some of them are being used for really good things. Researchers use AI to improve accuracy of gene editing, CRISPR. That's amazing. We're really in the biotech field. What's happening with AI is absolutely stunning. Is AI hype or is it here today? And it can also be used for really bad things. This AI writes clickbait headlines and the results may surprise you, okay? So we actually do have this going on. And in fact, one of the things that I just did, I just finished up a contract. I just spent several months at I guess I can say who it is. It was HomeAway here in town. And we were building for them a system to completely generate, and I don't know if anybody else is doing this yet, totally 100% automatically and using AI and machine learning technologies generate marketing emails. So the text, the picture, selecting the pictures, writing everything up, putting all the stuff in there, sending it out, tracking it, figuring out what works, learning from it, plugging it into A/B testing, cycle, loop, repeat. And the advantage of doing it this way is that if you do it by hand, you've really got it takes a long time. Even if you've got a big crew of marketing people, there's only so many of those you can do. With AI, you can do something completely different. AI really is improving, and this is one of the things that is important to recognize because we're seeing, things like object recognition. One of the things that we did was we submitted a whole bunch of the property photos that we had to Google and had them classify them. So they would come back tagged with a bunch of information. Oh, this is a kitchen. It has stainless steel appliances. It has granite countertops. Turned out to be really hard. Okay, Google doesn't really know how to find granite countertops yet. There are some other things that work well. And we're seeing these accuracies go way up. We're at about 2/3 right now. But the interesting thing is, until just a few years ago, we were stuck at 1% a year improvements in this. And we'll talk a little bit about the different kinds of AI, and I've got to move to catch on. Speech recognition has gotten really good. I mean, everybody here uses speech recognition on a relatively, frequent basis is my guess, okay? I have an iPhone, and I think, interestingly enough, that Siri is now absolutely the worst voice recognition on the market. Apple needs to do some serious catching up after having done some initial innovation there. And Google's voice recognition dropped from 22% to 8% in just 3 years. Okay, that's kind of staggering, and it has to do with the fact that we're learning these things, the machines are learning these things in different ways than they used to. Some of the academics will tell you that supervised learning is solved, but 80% recognition is not good enough to drive your car around on the street. And autonomous vehicles are one of the areas where everybody loves to talk about AI and machine learning and how it's going to change the world. And one of the important things to remember, especially in that particular domain, is it's actually really good to get to a certain point to where you're almost there, you're almost good enough. But getting that last little bit is very, very, very hard, and I think that we're going to see that's a lot harder than a lot of people think, is my guess. Quick review on what goes on in AI and what the different types are. One of the things that really is interesting is, this goes back to, as early as the 50s and 60s, people started to want to replicate human intelligence, and this is what's called procedural AI. It basically is, you'll find different terms for it, but it's a glorified set of if-then rules. And ultimately, there are aspects of the world for which you still need this kind of information and cannot achieve it using some of the machine learning techniques that we'll talk about in a little bit. But this is hard, And it's very, very difficult to come up with enough rules that reflect messy, difficult places like the real world. And I'll talk a little bit about, there's a company here in town that's doing this, which is really interesting. It's a fellow who left MIT a number of years ago because he knew that one of the problems was no matter how smart the machines got, they needed to know enough about what the real world was and how things in it related to each other. He's been spending over 30 years building a database, defining those relationships in ways that a machine can understand. Okay, he left MIT to go do that. Machine learning kind of came up in the 80s, and the idea was to be able to learn from the data itself, be able to start to draw inferences about what was going on. These became, they started out as inference engines to create expert systems, then later on grew into more complicated things. But the whole idea here is you're learning from the data, not really from the programmed instructions. This can produce non-deterministic results. We'll talk about this in a minute because this is important, especially for some of the things that are going on in the EU, probably in the next year or so. Deep learning is now where we are now. This really kicked off probably about 2006. And the idea here is that you're using now multi-layer neural networks to be able to produce these kinds of machine learning results. And the whole idea of a neural network is, the idea is that we'll put together a group of synthetic neurons, either in software or hardware, and there's some interesting things happening on hardware too that I'm not really going to touch on in this presentation. But the idea is that they're hooked together much like the neurons in a real brain are. The problem is we don't really understand how neurons in a real brain work either. So there's, as you might guess, when you really kind of get down to it, there's a little bit of hand waving going on here at the core levels of the technology. So one of the things that's different is you're seeing a lot of what you're seeing today, and a lot of what people are talking about are really talking about deep learning. And deep learning is kind of a subset, well, it is a subset of machine learning that uses these multi-layer neural networks. And there are some significant differences between this and traditional machine learning approaches. And it's important to understand which is what the differences are, because they have a lot to do with what the appropriate tool is to use in your situation. And there's some real advantages. Machine learning, if you're using just a straight machine learning loop, you don't need a very big training data set. Okay, we only took a couple of hundred marketing emails to teach the machine learning loops how to write an email and how to pick the properties for those emails. Deep learning is a little different. It requires a very large training data set. Okay, Watson is kind of a classic example of this sort of thing. It's a great tool. I think IBM tries to tell people it can do anything, and it can't, but it's really good if you've got a very large corpus of text that can slurp through and then build relationships on. It's very good, but you have to have an enormous amount of data to feed it. Here in machine learning, a lot of these things have to do with sorting things out, identifying things. And one of the things that you need to do there is you're identifying features within an object, a signal, a stream, whatever it is. You have to define those yourself with machine learning. In deep learning, it figures those out on its own. And that's both a good thing and a bad thing, as we'll get to in a moment. Training times, this is really short. Deep learning, obviously, you're going through a lot of data. It's large. And as you might expect, that goes to compute RAM and storage cost. But this is one of the reasons that things are going so fast now, okay? We now have large amounts of data. For the last 10 years, we've been collecting data at a staggering pace. Everybody's been walking around with a supercomputer in their pocket, okay? And I'm not joking, because this, which is just an iPhone SE, this is the bottom-end phone that Apple sells. This has more compute power than the Craze that I was working with at Chevron in the early 90s. All right, that's kind of staggering if you stop and think about it. Okay, you really have a supercomputer in your pocket. And these things are creating just mountains of data. So we're getting to the point to where all of this stuff has become cheap enough and the data has become available enough that we can now really start to use it. And that's really the thing that's been driving it. We had to get to the point of having enough of those resources available. Technically, this is not really that new. It's something we could have done a long time ago. Talking about multi-layer neural networks a little bit, this is kind of how one would work. You'll have, I'm not going to go into this in detail because this is really ugly, and that's kind of the point of the talk. I don't want to have to learn this. I don't know about you. I don't want to have to know this stuff. Okay, I just want it to work. But there is some real complexity behind this, and all of these things are connected and interconnected. And this is a very, very simple neural net with just a few layers and just a few neurons. In the real world, you find these with hundreds or thousands of interconnections. And this is basically an order of n squared problem, which is why it's important for you to have a lot of memory, a lot of compute to be able to deal with these things. Here's an example of one of these, okay? And this is an example that I pulled right off of, I've forgotten where it was. What does it say? Extreme Tech. And I love this one because you get here and you see, okay, here's my input. I've got an image of this car, and at these various levels, these are the things that it sees, okay? Now, those are a little fuzzy, but you can kind of see that none of those seem to be terribly identifying, do they? And yet at the end, it comes out and says, oh, Audi A7, all right? That's the problem, okay? A miracle occurs somewhere here. And this is one of the things that really is interesting, okay? This is a bit like anesthesia in medicine. It works, and we know how to use it, but we actually have no way to explain why or how it works. Once one of these machine learning models has been developed using this multi-layer neural net technique, we can't really explain how it works. We just know it does. All right? And what that means is that it can occasionally miss things. Last year there was or the year before, I've forgotten which, a lot of you saw in the news the story of the Tesla that drove under the truck, killed the poor unfortunate guy who was reading a book or whatever he was doing, instead of driving. Okay? One of the reasons that happened was that nobody really realized until they went back and looked at that a Tesla thought of itself more or less as a flying mattress. Okay? It was kind of like a mattress on wheels. It did not know that it had anything that stuck up above the sensors on the hood. All right? It actually had no concept that the physical size of the car was higher than that sensor. And that was kind of its view of the world. It's looking at the world at bumper level, and it says, I can make that. And it couldn't. This stuff does get complicated in a hurry, and this is kind of the point, right? Because you don't want to have to know all this stuff. I don't want to have to know all this stuff, unless you're, the kind of propeller-headed geek that really gets into it. You probably don't want to know this stuff. And the good news is that we're finally getting to the point where the tools are getting there to let a lot of us do it. There are things that are happening that really are amazing. We've talked about a lot of these. And the big things that people are concentrating on are things like image recognition, natural language. Planning and strategy is a really interesting one. One of the problems you have here is defining the context well enough, and we'll get to that. Information indexing and retrieval. This is doing really good, but we're seeing this now. We're using machine learning to build new machine learning methods, and that's kind of interesting too. But keep in mind, we didn't know how the first ones worked. So we're going to know how the second ones work? Probably not going to understand those real well either. All right? So there are some downsides. One of the things that's going to be big here, I think, this next year is what sometimes people are calling XAI, or explainable AI. And that is that you're going to have to be able to say how your AI got to a particular conclusion, how it reached a particular decision. Right now, the EU has a law that is proposed, and it looks like it's going to pass, saying you have to be able to do that. If you're using an AI to make business decisions or process decisions, or basically any decision that affects people in the EU, you're going to have to explain how your artificial intelligence got to that decision. That means some of these guys are in trouble because we don't really know that. This right here is the ML code, the little black box. Everything else is all the stuff that you have to do to be able to use it. And this is the reason why that we're seeing some really big companies that have really compelling and large-scale bundles of cloud offerings that are kind of becoming the preferred platforms for doing this kind of stuff. This is what you want, though. You want to be able to do this without a huge amount of knowledge, right? You don't want to be, that guy with the PhD in predicate calculus to be able to figure out how to do this stuff, okay? You don't want to have to figure all that stuff out, but we've seen it before. And the good news is we've got at least three really big examples where we had things that were highly technical, domain-specific, stuff that used to require a bunch of knowledge, and we've gotten through that. I'd say search, SQL or databases, and the web are examples of things like that. What's really going on here is that we're seeing something happen on the software side of things that's the equivalent of what happens with integrated circuits. What does an integrated circuit do? It just basically encapsulates and abstracts out a bunch of hardware, complexity. And the nice thing about it is I don't now have to know what goes on inside that chip, okay? I just have to know what its interfaces are and how to plug into those and use them. If I send this signal in, I get that signal out. It needs power here, it needs an input here, an output there. Okay, that's really what's happening now with a lot of these new libraries and APIs. And so what you wind up with is you'll have an image recognition cloud API that is doing, this is an example of one of the things that you get out of Amazon's recognition engine doing a facial analysis. So it'll tell you, sunglasses, gender, eyes closed or not, emotions, everything, okay? It's pretty neat stuff. But what you do is you basically just pass this an image in a data stream of some kind, and there are various different ways to do that, and then you'll get data back out. Usually that's going to be, a JSON, JavaScript serial object notation type format that will give that data back to you, and you can then pass that on to whatever else it is that you want to use it for in your other applications. These are some examples of what's going on here. Google has TensorFlow object detection. This is one showing it properly identifying the people and the kites in this picture, okay? So they taught this one to recognize kites, which is kind of an interesting thing. And then they're saying, like this one here, we're only 86% sure that's a person. Get down here, I don't know, that guy's half in the water, 54%. Not really completely sure that's a person, but we think it could be, okay? It recognizes that. The kites, it seems pretty sure about the kites except for this one. That might be a bird. 54% for a kite on that one. It's not sure. These are just a few examples. Okay, I only picked a few because there are so many that are going on that it's actually really impressive right now what's going on. Apple has a system called Core ML. Now this is something that they build into all their products and it's available to any developer building on top of Apple products, which is really neat. Again, this is just making these machine learning capabilities available to ordinary developers writing ordinary apps for their iPad, Apple Watch, iPhone, whatever. These do interesting things. In fact, on the new iPhone 10, this is what's doing that image and face recognition. This is what does image and face recognition within the camera app when you use that. It detects various kinds of objects. It understands natural language processing and generation. Again, they've got a nice core platform here. I wish they'd get Siri up to speed. This is interesting too because a lot of what you see going on in this machine learning and AI space is really happening in the cloud, and there's some good reasons for that to happen, primarily because these things interact with a lot of other things. And so what we're seeing is some of the companies that are providing the AI and ML pieces are also recognizing that the cloud is really kind of the best environment to provide all of those other things that it needs as well. One of the things that's happening here is different with Apple, I was going to say, is this is on device. So independent of the cloud, they've got the ability to run this stuff on the device. They're not the only ones. It's just that they're putting a little bit more emphasis on this just because of where they view their bread as being buttered. Another example would be Amazon's Polly API. Polly like the parrot, because the idea is this is a fantastic text-to-speech engine. You pass this thing text, it speaks it out. It speaks it out in, actually it's more than 24 languages now. This was when it was announced. It's up now from that. And multiple voices. I think they've got like 70 voices all together now that they can use. And it can stream that data to anything, any other AWS, Amazon Web Services app, or any other cloud app via their APIs, or send it out as an audio file. This is actually kind of interesting because now you can just do this as a cloud service. Anybody that can call an API, and you do have to have some minimal programming skills to do this, although I think we're going to see some things, this is going to change that in ways that are interesting. The next one, moving on, is Microsoft's Emotion API. So this is part of Microsoft's Azure Cloud Services. Right now, I would say, and this is just my take it for what it's worth, okay, I think Amazon and Microsoft are in the lead here. Google has got some really, really good tools. They're not as well integrated. Their individual tools are really good. Google has some amazing technology internally that they don't turn loose. They have turned loose of some things that are very, very good, but the effort to integrate them is a little higher. They're aimed more at more capable programmers and developers. Microsoft probably has the most complete tool set that's the easiest to use right now. And that's kind of interesting to me because nobody really talks that much about Microsoft, but what they're doing in this space is pretty important, and they've got they've done a really, really good job of putting together a very complete offering that is very easy for Microsoft developers to use. And they also have an advantage in that because they're in business and they've got not only Office, but they've got all of the Microsoft Dynamics stuff, the things that run a business, they can be in a position to more cleanly and more easily leverage those kinds of capabilities than some of the other guys can. Because Google doesn't have that, Apple doesn't have that, Amazon doesn't have that. They have an emotion API that, kind of like the Amazon one, will be able to look at a picture and tell you what the emotional state of a person is. Now, one of the things that's kind of interesting about Microsoft's is theirs was the first to be able to do this with real-time video. And one of the things that's interesting about that is they've got all kinds of interesting applications for this. One of these is they want to use this in retail establishments. So as you go through the store, there's a whole bunch of cameras. There's always cameras in stores, okay? But now, instead of just seeing if you're stealing something and dumping that to a DVR they can look at later to try to nab you if you get caught, carrying a bag of potato chips out the store, what they do instead is they can take that and run it through and do real-time sentiment analysis on the expressions. So as you pick something up and you go, no, nope, it's got canola oil, don't want it, okay? They can pick up on that, all right? They've never been able to do that before. It's a little creepy. Most of this AI stuff's a little creepy. This is just looking at some of the various APIs and competing them. So this was, or comparing them. This was image analysis, this is voice recognition, this is object recognition. In each case, you've got Amazon, Microsoft, and Google, and you can see what's going on. Amazon's got some really good stuff, but Microsoft's really good. Google's really good on some of this stuff. And these happen to be some of the things that they're really good at. But you can see Microsoft actually is checking a lot of the boxes. They've got some very, very powerful things going on. They're even starting to work together. This is a really interesting thing. Microsoft and Amazon not long ago introduced a new effort called Gluon, which is a platform that makes it easier to do these kinds of things. This is the first time that we've seen two of these guys competing in something other than the open source community. So that, to me, is indicative of the sorts of shifts that we're going to see. You're going to see alliances. You're going to see cooperation form in ways that we haven't really seen that much of yet. And Facebook out here, they're an outlier, but keep an eye on them because they're doing some very interesting stuff in this space. They haven't opened a lot of it up. Some of it. This is just talking about some of the things. This is Amazon proper, and this is only a few things. There are literally dozens of AI and machine learning based products in Amazon Web Services. So this is just a quick overview. Some of these things, Comprehend, understands natural language. Lex is actually really cool. This is for building chatbots and conversational interfaces. Those may be text-based or they may be voice-based. The interesting thing about Lex is it doesn't really care because you're going to feed text to it. So you're running it through some of the other services, Poly, or some of the other voice recognition system stuff to be able to interface. They've got their own machine learning capabilities here that you can, if you want to do this, you now don't have to do it yourself. You can just call Amazon's machine learning and say, learn this, here's a model, and here's a bunch of data, you go figure out what it means, and it will do that learning for you. And the nice thing about this is where you avoid having to have the PhD in computer science to do this stuff. You can just go make it happen because you can read the documentation for this, and it's not trivial, but it's not nearly as hard as it used to be to do these things. They're even integrating some of this with their hardware. I mean, you're probably mostly familiar with Amazon Echo and some of the Echo products, but they also have this product called Deep Lens, which is a deep learning enabled camera. That's kind of interesting because what you can do is you can put the learning models on the hardware of the camera and it will learn things about its environment from what it sees. All right, that's kind of interesting. This is only a few $100s, okay? It's not available to everybody. You have to get in their developer program to buy one, but it's pretty cool, okay? Of course, they've got image recognition and stuff too. We talked a little bit, Microsoft, they've got a lot of stuff. I mean, vision, knowledge, speech, search. I think one of the things that's going to happen too, and we haven't talked about it much here, in addition to this commoditization allowing ordinary programmers and developers to be able to leverage this stuff, we're going to see some other things happen. And I think one of the things that's going to happen is this rise of IA as opposed to AI, where IA is intelligence augmentation, where we're going to be building tools that help people do their jobs rather than replace the people. Replacing people is actually surprisingly hard. You'll see all kinds of articles by all kinds of journalists who don't know what they're talking about how everybody's going to be automated out of a job, okay? That's really ridiculous, and I think actually one of the things that's funny is they usually are talking about the low-end jobs first. That's not it, okay? The first people to be automated out of jobs are going to be white-collar people who do nothing but information work. And in fact, one of the things that's kind of interesting is, as you saw from one of the headlines there, Microsoft is now working on AI tools to write code and replace programmers. All right, that's kind of neat. And if any of you have been involved in software development over the last several years, I have for a long time, you know you're spending way, way more on programmers than you really ought to have to get things done. So that's going to change things. I think we're going to see another trend here, and it's going to drive a resurgence of flow-based programming because all of these techniques, especially the ones that involve deep learning and machine learning using neural nets, are inherently data flow driven. And so we're going to see the idea of flow-based programming is one where you basically build your program as a module defining inputs and outputs and pipelines. Okay, it's kind of the old Unix pipeline idea, but on steroids and being able to connect these things up in different ways with different modules. It's a little bit like what National Instruments does with, what do they call their thing? LabVIEW, right? It's a visual programming system. Now, it's a very domain-specific thing, but I think we're going to see that idea take off in a more generic way just because these things are driven by the data flows the way they are. And this is, by the way, changing the entire back end of data centers. We're seeing data centers go from just data centers with a bunch of servers to now data centers or cloud implementations that define a whole set of new things. So you've got things like, Apache Spark streaming, Kafka streams, message queuing interfaces, all of these new complicated things that they're complicated internally, and they're complicated to use today, but they're getting easier. This is going to change interfaces, obviously. We're just beginning to see this. Voice, gesture, and touch. One of the most interesting things about the iPhone X to me, and there's very little that I find interesting about it, but one of the things that's interesting is some of the hardware that they put in there for their face recognition. Because although they're using that for face recognition and just to unlock the phone right now, that technology can be used to do a couple of other really interesting things. Okay? Among other things, it could be used, I'm not sure it's good enough in its present form, but it could be used to be able to do gesture recognition. So you could do, without even touching the phone, you can say this, that, do something, grab that, okay? That's kind of cool. You're going to see more of that, and if those of you who saw my talk a couple of years ago about big screens know that I think that's going to change anyway. Sci-Corp is the company I was talking about here in town. Doug Lennett, who has been building this big database of relationships of things in the real world for over 30 years, 35 years now. This is like the most underreported AI project out there. And they do this for a couple of reasons. They're not really seeking money. They have a bunch of government contracts. They kind of stay under the radar, but they've been quietly doing it and building this database for about 35 years. And I think you're going to need things like this because ultimately, you may have something that can process and parse all kinds of interesting stuff, but if it doesn't have the contextual knowledge about the way those things interact, it's not going to be able to do anything that's terribly useful. And so this is an important thing that's worth keeping an eye on, okay? Because the tools and techniques that we have now in machine learning are going to hit the wall soon and require this kind of knowledge. Good friend of mine is Dwayne Perry, who recently retired as the Motorola Chair of Software Engineering at UT, or Freescale, I guess. And he told me a number of years ago, he's a good friend of mine. We were talking over a couple of beers, and he said, one of these days, artificial intelligence may approach natural stupidity. So maybe we're getting there. Okay, thank y'all.